Hi, I'm Adam Goldstein, member of the Teen Advisory Board with Howard County Library System, and today I'm going to teach you how to use arrays in Java. So, getting right into things, because unfortunately I don't have very much time with this video. So, this is an example of some code that does not use arrays. This uses simply variables that you've learned about in the past. We have a whole bunch of integers being declared here. Now here I'm going to concatenate them together with some commas in order to get this string that you see right here. Pretty simple enough, but it's not the best way we can do this. We can actually represent this data a little bit better using arrays. So this same code will do the exact same thing, but using arrays it's going to look a little different. It's going to look like this. So note the differences here. Over here, we actually have 5 separate variable declarations, int item 0 all the way through 4. However, with arrays, we only have one type declaration. And this type declaration probably looks a little bit unfamiliar, because this is an array type definition, as opposed to the non-array types that you've been looking at previously. In order to indicate that you want an array of certain values, you use these little brackets right here. You can type those by using the keys to the right of the P key on most keyboards, and that will get you the same characters that are used here, and here, and here. You'll see brackets used a lot in the context of arrays. So the first context we'll see them in is in type declarations. You'll see some brackets, look immediately to the left. That is the type that is going to be stored inside that array. This is our variable name, just like usually. And then over here we have the new keyword. And this tells the compiler, or to tell Java, that you are trying to create something new. In this case, you're creating a new array of integers. And this follows the same convention. When we see this bracket, we have to look immediately to the left and see that it's an integer. We look at this number in between, and that's where we actually specify the size of the array. And once we've specified that size, we can actually start adding things to it. With this new keyword will give us a empty array, so we have to add in all of the elements that we want, or we have to set all of the elements. And we can do that using this same symbol, the bracket. What we do is we reference the variable name, in this case items, and then immediately after that we have a pair of open and closing brackets. In between them we use the index to access different items inside of the array, and this works basically just like if you think about a shopping list or something like that, where you have multiple numbered items. You have item 1, 2, 3, 4, 5, something like that. Except in Java, we don't start lists at 1, we actually start them at 0. So it's like 0, 1, 2, 3, 4, 5. Or in this case, just 0 through 4. So we can set each of those values individually using their index. That's the sort of number that we call that number associated with the value. We call that the index. The plural of index is indices, by the way. You may hear me use that word. And we're going to set that to 10. And we're going to keep going. We're going to set each of these items, so 0 through 14, to the numbers 10 through 14. Then in order to access those values inside of that array, all we have to do is just this. So it's the exact same syntax, whether or not we want to read from the variable or if we want to write to the variable. And just like we concatenated all these together down here, we're going to do the same over here. And if I run this code, you'll actually notice it does the exact same thing. So let's look at a little bit better of a way to use arrays, something that makes it a little easier, and why you might actually want to use arrays in your actual code. But first, there's a little bit of a caveat, something that happens with arrays and other types you're going to learn about in the future that hasn't happened with any of the types you've looked at in the past. And that has to do with conflicts from something called references and reference types versus primitive types. So I'm going to run this little piece of code here. We don't have a ton of time to dive deep into this, but essentially all this is doing, and you're welcome to pause and take a look at this code if you'd like. I'm scrolling here, but you can see this last bit of code is just concatenating the values together. So I'm going to scroll back over here. Now what we get here is we have a few different types. This deals with integers, this deals with strings, and this deals with arrays of integers. And for all of those, what we're doing is we're creating an original variable and then a new variable. We're assigning that new variable to the value of the original variable, printing out what it currently is, and then changing that original variable, and then seeing what both of those new variables are. So we can see, and this is what you've probably seen in the past, working with things like int, or floats, or doubles, those sorts of things. They're all going to behave this way, where if you set new int to equal original int, sure, they'll have the same value originally, but if you change that original int, then that sort of binding, that linking, is completely gone. So you can think of that as sort of a weak link between them. And that's because integers are something called primitive types, along with booleans, shorts, floats, doubles, integers, longs, and chars, which are like characters. I might have missed one in there, but I believe those are all of them. And the way that they work is they actually store values inside of their variables. So you're telling that this value of 1 is being stored in the original int. So when you're assigning new int to original int, you're really just copying over the value, essentially. So when you assign original int to original int plus 1, it's just saying, okay, now original int is 2. It doesn't care about what new int is. But we're going to actually see this last example works a little bit differently. If you see here, we're doing the same sort of thing as before. We're taking the second item, or technically the first, but remember that's really the second because we start at 0. And we're going to take that and just increment that value by 1. So you'll see over here, both of our arrays actually have that second value incremented by 1. You can see the difference in what happens here, even though it's the same sort of thing happening in our code. And that's because arrays are reference types. They are not primitives. And the reason we call them reference types is because instead of storing the actual value in this variable, it stores a reference to that data. It's essentially a place where you can find it in memory. You can think of it like an address or a label of where you can find a box on a shelf, that sort of thing. So when we have this little piece of code here, which you'll learn what that does in just a second, but basically this is creating an array. When we create a new array, it puts a little piece of memory somewhere in the computer's memory for us to store the data in that array. And it puts a little reference inside of this variable here of where we can find it. So this piece of code, instead of setting new int array to the value of the original int array, it actually sets it to a reference to the exact same place. So it's looking at the exact same data for both of these variables. They're essentially just two different names for the same thing. And we could reassign this new int array to point towards another array, so it's no longer linked to the original int array. We could do that for either of them. But the important thing to note is that the way it's acting right now is basically like if you had a box with two labels on it. It's the same thing in the box, you're just calling it by two different names. So we're going to log the value here, and we can see, oops, we get 1, 1, and 1, 1, but then as soon as we change that second value of the original, it updates in both places. And with that explanation, it makes sense. How could it do anything else, right? It's updating in both places because both places are actually referring to the exact same data in the computer's memory, so they have to change the same. All right, technically, strings, you'll see this middle example here. Technically, strings are reference types, but they actually end up performing a little bit more similarly to primitives than actual reference types. And that's because strings are something called immutable. I'm not going to go into a ton of detail on that. You can find lots of articles online about this as well. But essentially what it means is that when we modify this string here to do the original string concatenated with b, you're going to get a new string ab that isn't actually related to this old string. Immutable means that you can't actually change the string, you can just create a new string. So that's why this is essentially creating a reference to a whole totally different string, and this new string is now referring to the old one. So that's essentially how it works. But what the effect is, right, is that it ends up acting similarly, or more similarly to a primitive. You can see we have this same sort of thing happening here where the first one gets changed, second one doesn't. But in reality, strings are technically reference types, just as a note in case you hear anything about that or get confused with that. Alright, now I got a few minutes here to take you through some examples. So I'm going to run this little piece of reference code, and we're going to actually dive a little bit deeper into some of the syntax surrounding arrays and nifty things that we can do with them. So, You'll note I have some little things called first, second, third. That's just to make it a little easier to see where we are. So underneath first, you can see I'm creating an array just the same way that we did before, and I'm going to use this code to concatenate all those items together and display them. But this code is really long, so I actually wrote a method that's going to do all of that for us. It's my understanding that the video about methods and loops and that sort of thing has not come yet, so I'm not going to show you the details on how to implement that. But you can rest assured knowing that this code is essentially doing the same exact thing as this shorter piece of code. This shorter piece of code is just something that I wrote to make it a little easier on the eyes so I don't have all of this stuff everywhere. So whenever you see something like this in this code, you should think about something like this happening. And you can see that they print out the exact same way. Now, moving on to second over here. This is another syntax that's actually going to do the exact same thing as all of these lines. Instead of declaring the type of the variable and instantiating that new empty array and then assigning each value one by one, that's a lot of work. And remember, when programming, we want the computer to do the work, not the programmer. As much work as we can put on the computer instead of the programmer, that's a good thing. So we're going to let the computer do some of the work. We're just going to give it the values separated by commas and put inside curly braces, and it's going to automatically tell how many items are in this array, so it's 5 items, and it's going to create a new array, and it's going to set all those values just like that, which is a lot cleaner, quicker, easier way to do this. But keep in mind, these are the exact same things. Something that is important to keep in mind, however, is that this what we call a literal syntax. So like this is a number literal, this is an array literal, just anything that gives you data from code that you put, that's a literal. So this sort of array literal only works in expressions like this when you're assigning it to a specific variable. You can't just like pass that in a function or something like that, or pass it in a method rather, but you'll learn about methods later and some of the caveats there. So I'm going to print out this directly after second, and you'll see it gives me the exact same thing, because this is doing essentially the exact same thing. It's just a shorter way. Something of note, I've been using integers because they're just the easiest to sort of see what's happening with them. But you can use any type of data, including booleans. So here I have a boolean, true, false, true, and you can see when I print that out, sure enough, I get underneath third, true, false, true. Now there's also a way that we can actually get back the length of that array. The length of an array, the size of an array, same thing, but what we're talking about is the number of items that it can hold. So we declared this with 3 values, which means it has a size of 3. So if we do items.to, that's the name of the list, dot length, it'll give us back that length, which is really useful. And you can see it says 3 here. Underneath fourth, so this is actually telling us, well, you can pause the video for a second if you want. What do you think this is telling us? If we have int, and then brackets, and then brackets. If you guessed that this is going to create an array of arrays, you're exactly right. And you could also probably tell from the name. But what this is doing is this is essentially saying we're going to have an array of whatever this is. And this is saying we're going to have an array of whatever this is. So we're getting an array of arrays of integers. And over here, when we're initializing it, we only need to declare the size of the first outermost array. The other ones are just going to be referenced, so they don't need to know the size yet. So we can just leave that empty. So we're going to create an inside array just like this and assign that to the first index of arrays, and then we'll do the same thing with the first index. And now you see these aren't actually the same size. They can be, and they often are, but they don't have to be. So we're going to print those out, and sure enough, I get those printed out. But you'll note I actually created more than I need. If you create a larger array but don't set those values, what you're going to get is something called null, and that just basically means nothing. You can see down here we have this shorter syntax for declaring arrays of arrays, just like we looked at before. Down here, you can see how we can modify some of the items of these arrays. We can also, up here, just get the length of inner lists, just like you would access, or inner arrays, just like you would access the outer arrays. And over here, you can modify all those sorts of arrays. And down here, this is just showing you how you can get one of those arrays. But if you access something that's beyond the bounds, then you're going to get an exception, because it is out of bounds. So you have to keep your indices in bounds. And if you do that, then you'll be great. All right, I'm out of time, but hopefully you learned something and found this helpful. Take care.